Hi everyone. Today here I am going to discuss about the force system resultants, which is the part of mechanic 1, or we can also say uh, it's about the moments. So moment, let's start by talking with the moment of forces. So what is moment? Normally moment is the another term for moment is the torque. If you are using in the mechanics, we basically use the term torque, and another term for this one is moment of force or the moment itself, and it will occur it can be solved when you are going to apply the certain amount of force to the body and that force will produce the certain tendency for the body to rotate at the certain point that is not on the line of action of the force. So that is moment or the torque, and the moment is it's a vector quantity because it has both magnitude and the directions, and magnitude of the moment is directly proportional to the magnitude of the force F and the perpendicular distance, or the moment also known as moment arm. Let's suppose that is D. So here in this diagram you can see the force is applied in the perpendicularly to the moment arm. So in this case it's easy to compute. If you are going to find the moment around the counterclockwise, considering that as a positive, you will just be multiplying the force applied times perpendicular distance from the point O, so that is D. So there's also other conditions, like if you are applying the force at a certain angle instead of perpendicular. Oh, let's suppose here in this diagram you can see the force is applied at a certain angle instead of perpendicular or the right angle. So here you can use the trigonometric formula to find the sign when the force is applied at a certain angle theta. So by using the trigonometric formula, sine theta is equals to perpendicular side, which let's assume that is d dash, divided by the hypotenuse, which is the longest side of the right angle triangle. So here in this case d, so that is d dash divided by d is equals to sine theta. So if you are going to find that d dash, that should be cross multiply d sine theta. And if you are going to use the form find the moment, in this case this is the perpendicular distance. So here you are going to use force moment at the counterclockwise, considering that as a positive. The formula to compute this one should be force times d dash. So d dash we solve, that is force times d sine theta. This should be the formula if it is applied, the force is applied at a certain angle. But if the force is applied straight away from the point O, so that time there is no moment, there is no twisting force. That means the moment here is should be equals to 0, because the perpendicular distance, there is no perpendicular distance since it's a parallel. So force is applied, let's suppose F, and the distance, perpendicular distance is 0. So force times 0 will also equal to 0. So there is no moment in this case. The moment MO, or the moment around about the point O, or about the axis passing through the O and the perpendicular to the plane, is a vector quantity, as I mentioned a while ago, since it has both specified magnitude as well as directions. Direction in case because it has the force indicating to the certain directions. Moment also derives the certain directions because of the directions we get from the force. So how can we compute the magnitude of the MO, or the moment around the point of axis O? Basically moment, as I solved here, many times. So it's simple formula. Moment is equals to force times perpendicular distance. As I explained here, this D is the moment arm, or the perpendicular distance from the axis at the point O to the line of action of the force. And the unit of moment can be a Newton meter, or it can also be a pounds feet, depending on what unit system you are using. The direction of moment is defined by the moment axis, which is perpendicular to the plane that contains the force F and its moment arm D. So let's suppose here moment of force, while talking about the moment of force, let's assume that there are several forces. If there's several forces, each of the forces will generate the separate moment. But when you combine, if you apply the several forces on the same object, it produces the several moments, but there's a certain resultant moment. It can be computed by sum of all the moments acting on that, or the sum of all the moments produced by those forces on that object. So let's example here in this diagram. You can see there are three different forces, F1, F2, F3, and each of them have the certain perpendicular distance. They are acting, those forces acting from the point O with a certain perpendicular distance, like D1, D2, and D3. So each of the moment can be derived. F1 times D1 is equals to M1, moment 1. Moment 2 is F2 times D2. M3 is F3 times D3. But you need to consider the directions as well. When you say directions, usually we assume counterclockwise as a positive and the clockwise as a negative. So here you can see the force F1 from the point O, it's acting counterclockwise. F2 clockwise, F3 counterclockwise. That means these two forces, F1 and F3, they are positive, while F2, since it's acting clockwise, it is negative moment. So the resultant moments MR around the point O can be determined by finding the algebraic sum of the moments caused by all forces in the system, and positive moments as counterclockwise direction and negative moments if clockwise directions. So when you see the negative sign, you need to consider that that moment is acting clockwise, acting in the clockwise directions. So if the numerical result of this sum is positive scalar, the moment along the point O will be the counterclockwise moment. If negative, as I mentioned, it will be clockwise moment. So we can remember this formula as well. So counterclockwise is positive. The resultant force is, for resultant moment for all the forces acting on that object, should be the sum of product of force times the respective perpendicular distance, or when you expand it this way. So force 1 clockwise, counterclockwise, it's positive. Force 3 counterclockwise, positive. Force 2 clockwise, so it's negative. We have examples here. Let's solve with the example number 1. So in example number 1, you can see the certain beam at the distance of 2 meter from the point O. The 100 Newton force is applied. So you are going to find the moment here in this diagram. Since the force applied is perpendicular, so means the perpendicular distance from the point O, that is 2 meter. So we can say moment counterclockwise direction is positive, and the force times distance, we can say the force is applied clockwise, so that means it should be negative. Force is 100 Newton, then the perpendicular distance is 2 meter. Since it is acting clockwise, we can say negative. So 100 times 2, that is 200 Newton meter, and we can say negative since it is acting clockwise directions from the point of rotation or the point O. We have another here in the B. So in B also there's a force applied. The perpendicular distance from point O is here 0.75 meter. So we do not assume here 2 meter because the perpendicular distance here is 0.75 meter only, and the force applied is 50 newtons. So simple, we use the same formula, force times perpendicular distance, that is force applied is 50 newton and perpendicular distance is 0.75, multiply, and see the directions as well, it's a clockwise, so we assume that as a negative. We will find the answers here. So as we mentioned here, it's not mentioning the negative, but at the back it's showing clockwise as the positive. Here also in the second one also clockwise as a positive. So 50 times 0.75 meter, that is 37.5 Newton meter. So in the example number C, we have another force applied, that is 40 newtons, but it makes the angle of 30 degrees. So we need to find the perpendicular distance. So the total perpendicular distance is 4 meter plus this distance. So how are we going to find 2 cos 30? We can just solve you can solve directly. The force applied is 40 newton. 40 newton times 4 feet plus 2 cos 30. That should be the case, and clockwise is the positive here. As I mentioned, 2 cos 30 plus 4, 40 pounds, which is also clockwise. That should be equals to 229.29 pounds feet, since the unit given is pounds and feet. Then we have another example here, D, example D. Here in this one, the force is acting counterclockwise. The distance of the force applied is 60 pounds, and the perpendicular distance is this one. This is the perpendicular distance, so that is 1 sine 45 feet, because it makes 45-degree angle, then 1 feet. So process is same. Force applied is 60 pounds times the distance here, perpendicular distance is 1 sine 45, so we can basically write sine 45. So the answer is counterclockwise is positive. So 60 times sine 45, that should be equals to 42.4 pounds feet. Counterclockwise is the positive. The moment for this one is the counterclockwise. So the last example for computing the moment here is number E. In number E, you can see the point is O, and the force applied from the O is 7 kilonewton, and the force applied is 1 feet. The total distance is 4 feet. So the force applied is around 4 meter. So the force applied is 4 minus 1 meter, so 3 meter distance. So perpendicular distance is 3 meter. So it's easy to solve since the force applied is perpendicular. We don't need to use any trigonometric formula. So we can directly use 7 kilonewton times perpendicular distance of 3 meter. So that should be equals to 21 kilonewton meter, and you can check counterclockwise is positive. So indicate all the time that there is a direction of the moment as well. And we have another example, example number 2. In example number 2, it's asking to determine the resultant moment of the 4 forces acting on the rod rod shown in the figure about the point O. So here you can see there are 4 forces acting on this rod, and you are going to find the resultant moment around the point O. So we have a formula, sum of force times distance. So let's start with this one. The perpendicular distance is 2 meter. We can basically add 50 Newton times perpendicular distance is 2 meter. Okay, let's assume all the directions are clockwise. It's positive here in this case. So another force is 60 Newton. It is applied straight, so the perpendicular distance is in the center line. Perpendicular distance is 0. 60 times 0. Then another force applied is 20 newtons. So for 20 newtons, how are we going to find the distance? First, we need to find the distance by using the total distance here. The distance here given is 3 meters, and it makes an angle of 30. So we have to find the distance, perpendicular distance here. So let's see what is the example given. As I mentioned, minus 50 Newton counterclockwise, so it's minus 50 Newton times 2, correct. Another is 60 times 0 because it's along the line of axis, so 60 times 0 Newton, and it's doesn't matter the sign since it's a 0. The next is 20 Newton times 3 sine 30. 20 Newton is applied here. We need this distance. To find this distance, we use the formula, that is sine 30, since it is perpendicular, is equals to perpendicular, that is, let's suppose x. So x is equals to x divided by hypotenuse. Hypotenuse 3 meter, so 3. So x would be equals to 3 sine 30. So 20 times 3 sine 30, that's what we have, and it's also positive. Next is 40 Newton force is applied perpendicularly at this point. So the distance here you have is 4 meter, 2 plus 2 meter. Here you are going to find this distance. This distance, we can find it by using the formula, simple formula, trigonometric formula again. So 30 degrees given, 3 meter is given, so that means we can use the cos 30 formula. Cos 30 should be equals to adjacent side, that let's suppose y, divide by hypotenuse, the longest side of the right angle triangle, that is 3 meter. So therefore y should be equals to 3 cos 30. So this distance is 3 cos 30. So the force applied 40 Newton, perpendicular distance is 2 meter plus 2 meter plus 3 cos 30 meter times 40. And since it is clockwise, we use the negative sign. So you can solve this one. 50 times 2, 100. 60 times 0, 0, minus 100, sine 30, 0 0.5, 20, 30, 20, sine 30, 0 0.5, 0 0.6. Let me solve. Sometimes it makes confusions. Yeah, 3 times 0 0.5 is 1.5. 1.5 times 20, that is 30 positive. Then you can just add. So when you solve all of these things, you will get the answer of negative 334 Newton meter. So we have a negative. Negative means the force, the resultant moment that is acting clockwise. So indicate this one. You can remove the negative sign, since you are indicating the direction of moment. So that is the example number 2. So since we are done with the example number 2, let's proceed to the cross product. So when we say cross product, it's a product of two vectors a and b, and that yields the vector c, which can be written as c equals to a cross b. And the magnitude of this c is defined as the product of magnitude of a and b and the sine of angle theta between their tails. So a cross b, actually this is not multiply, it's just a magnitude, product of their magnitudes of those two vectors a and b, which can be written as ab sine theta. And vector c has a directions that is perpendicular to the plane containing the a and b, such that c is specified by the right hand rule. So a cross product b should be equals to ab sine theta, then uc. So where ab sine theta defines the magnitude of c, and the unit vector, this uc, is the unit vector that defines the direction of the cross product vector c. So right hand rule, which we discussed in the previous chapters. So c cross product is a plus a cross product b is c, and the direction of c is the unit vector uc, and the angle between these two vectors a and b, that is theta. Basically you can write this ab sine theta unit vector for the directions. So there's a certain law when you are solving the cross product. We call it law of operations. There are commutative law. In commutative law, a cross b, a cross product b is also equals to negative b cross product b, because the directions is different. Then there's another law, associative law. In associative law, if certain magnitude will multiply the cross product of a cross product b, it will only multiply one vector only, whether it is with the vector a or vector b only. It doesn't multiply to the another vector. So that is associative law. And there's another law, that is distributive law. In distributive law, we multiply this, or we call it, there's a two vector, they are added, but the cross product is by one vector, so it will be distributed a cross product b plus a cross product d. So this is distributive law. You will distribute the vector to the two separate vectors where there's a additions. So you need to remember this one if you are using the unit vectors. I cross vector j is equals to k, j cross vector k is equals to I, k cross product I is equals to j. And let's suppose you reverse it, k cross product I cross product k, that is negative j, j cross product I, that is negative k, k cross product j, that is negative I. And if you multiply the unit vectors, I cross product I is equals to 0, j cross product j is equals to 0, k cross product k is equals to 0. So expand it, you can see here a cross product b should be the cross product of unit vectors of E cross product of unit vector B in three different axes if you are using the right hand rule, and each of them will multiply to each of them. This one will ayj multiplies to bxi here. And the final, since we have a directions, by using this as a reference, the final expanded form of a cross product B should be aybz minus azby I minus axbz minus azbx j plus axby minus aybx k. So here also, if you are using the matrix form, you can use this formula as well. The formula for the element I, here the directions you can see. For the element j, you multiply ax times bz, then it's going up, so minus az times bx. Always remember the negative signs. The next is for the k, ax times by, positive, going down. Next is going up, ay times bx, minus. So always remember the negative signs here if you are using this formula or this method. Next one is the moment of force vector formulations. The moment of force F about the point O, or the moment axis passing through the O and perpendicular to the plane containing the O and F, can be written as moment or is equals to R times F, where this R is the position vector directed from the point O to any point on the line of actions of the force F. You can see here. So this R is the position vector directed from the point O to the any point on the line of action of force F. It can be here, it can be here, it can be here. So it can also be written as RF sine theta or FR sine theta. R sine theta we have here. So R sine theta here, R sine theta, that is the perpendicular distance. So that's why we replace it with the D. Listen, this distance, that is R sine theta. You might ask why, because there's a theta. If you're using the sine theta for this D, sine theta, that is perpendicular, that is D over hypotenuse. Hypotenuse is R, so D is equals to R sine theta. That's why we replace R sine theta with D. Next, we have principle of transmissibility. So in this one, we can see, as we said, the R can be at any point of the line of force F. So we can say moment O can be R1 times F. If we get R2 here, the R2 times force should also be equal. The moment should be equal here. And if you get the R at this point, since it's still in the line of action of the force F, it should still be equal. R3 times F, it should be equal. All the forces, the moment at the any point for the given force, if it is taken at any point of the force in same line of action, it should be equal. here. So if you are using the 3-axis form, r times 4, that can also be computed by using the matrix form. If there are several forces, F1, F2, F3, you can assume the distance from the point O. For F1, the distance is R1, R3, R2, and the resultant moment, it makes the certain moment, the resultant moment for all those 3 forces. So let's solve this with the example. So in this example 3, it's asking to determine the moment produced by the force F in the figure shown below about the point O, and express the result as Cartesian vector. So the tree is it's a tree with a certain length of 12 meter from the point A to point O along the x-axis. The tractor is trying to pull, so the cord or the cable is attached to the point A, and it makes a certain angle. Let's assume 3 is straight, so it makes perpendicular distance. So by using the express the result as a Cartesian vector, so how can we solve? You can see here, as shown in the figure, either RA, let's assume the RA from the force applied is in this point, from the point O, or the RB can be used to determine the moment about the point O. So these position vectors are, RA can be written as 12k meter because that is 12 distance, and it's along the J, so that's why we added k. If it is along the x-axis, we can write I. If it is along the y-axis, we can write J for the Cartesian vector form. So if it is we use this RB, which is along the y-axis, so we can say, how can we find this one? RB should be equals to 4i plus 12j. Why? 4i plus 12j. So up to here it is 12j, and the distance from the y-axis is 4 meter. So that is RB. So force F expressed as a Cartesian vector is force, we go back to the same formula, force times unit vector AB, which can be written as 2 kilonewtons for I12j minus 12k meter divided by magnitude of vector AB. So here you might ask, how did we got it? It's actually the vector AB divided by magnitude of vector AB. This one we discussed in chapter 3 of the mechanics. You can go back and check for this formula. So that can be written like this way. So when you solve that one, the answer should be 0.4588i plus 1.376j minus 1.37k kilonewton. Thus, I just transpose these values in this form here. 12 RA, we have RA here, this one 12k, that means I component and J components, they are 0 0, only we have 12 for the K component. Then we have another, that is F. So F, we got the forces, I component, J component and K component, so just transpose whatever you have including the negative sign. So it's a cross product of RA times the vector F. So it will multiply to each other here, 0 times this one, 0 times 137, sorry, 12 times 137, 6, then I, yeah, just keep on multiplying everything. So when you solve, the final answer moment along the point O should be equals to minus 16.5 I plus 5.5 J kilonewton meter. That should be the answer. Next, we have example number 4. In this example number 4, two forces act on the rod shown in the figure. You need to determine the resultant moment they create about the flange O, and you need to express the result as a Cartesian vectors. So here in this one, you can see there are how many forces? There are two forces, F1 and F2. F1 is given in the Cartesian vector form, which is minus 60I plus 40J plus 20K pounds. Then force 2 is also given in the Cartesian vector form, which is 80I plus 40J minus 30K. So we have I component, J component, and K component. That means along the x-axis, y-axis, and z-axis. So here you are going to find the moment, the resultant moment of these two forces. So how can we find? Draw the free body diagram. When you draw the free body diagram, it will form in this way. So first find the R. Assume the distance from point A to the force F1 is RA. Then the distance from point O to the force B, where the point where the force B is applied, force 2 is applied, is RB. So RA, that is simple. It's given the total distance, that is 5 feet. So we can write it's along the y-axis, so we can write 5J feet. RB, so RB is along the x-axis and y-axis, and also in z-axis, I think. Yes, it's also along the z-axis. So z, that is 2 feet going down, so negative 2 feet to K. Along the x-axis here, that is 4 feet, so it's positive, so we can write 4I. J, that y-axis, that is 5 feet, so we can write going in the positive side, so that is 5J. So that's what we have here. So after that, after you get RB and RA, go to the resultant moment along the point O, which is still the same, sum of all the forces times perpendicular distance. So perpendicular distance that we have, RA, we have two forces, so RA times F1, perpendicular distance, RB times force 2. Here, that's a sum. So when you add that one, put it in this form for these two, it can be in this form. After this one, just solve the problem by using the formula that we have at the beginning. That's why you need to remember this formula all the time. So this is the RA and this is the force, then this is RB times force 2. We just get the value from here and here. So the final answer should be, since the question is asking in the Cartesian vector, the answer should be in 30, the resultant vector, the resultant moment along the point O should be equals to 30I minus 40J plus 60K pounds feet. Also need to be careful with the units because given is the feet and the pounds. Okay, so let's break these presentations so it will not be boring. Another remaining part will be in the part 2, second part of the video, so ending the video as a part 1.